I'm very particular about my pens. Okay, group test. So, this first section, I noticed it was arranged in a way that some people had questions. This went with question number 1, 2, 3, 4, 5, 6. I fixed that for the actual test so that it does have 1, 2, 3, 4, 5, 6, but it is set up the same way, so hopefully you'll understand it. Okay? So, a horizontal translation 3 units to the right. What letter is that referring to? A, B, H, or K? That would be an H value of positive 3 because it's going to the right. So when I write it in the transformed equation form, that's going to look like a what? Positive 3 looks like an x minus 3 in parentheses. Now each one of these we tried to leave it so that it was only one transformation each time. So it's not going to be something that has both an H and an A in it for this particular set of questions, just one or the other. Number 2, there's something going on here. Is that an A, B, H, or K? That would be an A value. B is after the F, A is before the F. So that means I have an A value of 1/4. What is A determining? Vertical or horizontal? Vertical. Is that a stretch or a compression? And then I would like you to tell me of how much. This would be of 1/4. So for me, each blank is 1 point, all or nothing. In order to get the point here, you have to tell me the direction, vertical or horizontal. You have to tell me whether it's a stretch or a compression, and then tell me how much it's being stretched or compressed. Okay? Questions there? Just so that we have it down, remember our equation is A times F of 1 over B x minus H plus K. That's the equation I'm referring to here. All right, a reflection across the y-axis. Now let's think about that for a minute. This is what my x and y-axis look like, correct? Across the y-axis is actually a horizontal movement, right? So is that an A value or a B value? That would be a B value. So y-axis may make you think vertical and may make you think A, but since it's a horizontal movement, that means B is what's negative. So if B is negative, I have F of negative X. So far, so good? Good answer. Number 4. What have we got going on here? What letter do they show me here? B. Because it's after the F, before the X. What is B here? 7. You have to be careful because it says 1/7, but B is only the denominator. So even though it looks like you have a compression of 1/7, you actually have a stretch of 7. What kind of a stretch? Vertical or horizontal? Horizontal. So again, direction, type, number. All right, a vertical reflection, that would be from top to bottom. So that's a vertical movement. Is that A or B? That would be A. So I have to put a negative sign out in front. So negative F of X. And then finally this last one, is that A, B, H, or K? That's K. So I would like you to write either shift, or you could say translate. Tell me the direction and how far. So shift up 1, or left 3, or right 5, or whatever it is. Direction and how far. Any questions about that? Okay, those are 1 point apiece, 6 points total there. All right, next one seemed to mess with people for some reason. There is one graph given to you. That's this one. Anyone remember the name of that graph? That's the mother function, the parent function. So this graph, or this equation here, is a transformation of this graph. Now, if you need to refer back, this is what we did in our 5.3 notes. So if you want to look back there for more practice on these guys. First thing I need to do is from here, I need to identify H and K. So what is H? Looks like a positive 5 there. We know it's negative 5. And what's K? Positive 3. Where does that go? In the middle of my XY chart. Do you remember that lesson now that I say put it in the middle? And then what do we do around there? You put, what, negative 3, negative 4, negative 6, and negative 7? Now, I'm actually going to do not those numbers. I'm actually doing, I did these numbers. Why did I do those numbers? Why did I skip every other one? Because of this 1/2, it's only going to do every other one nicely, right? Now, I don't care if you choose to skip the numbers there or if you just choose to go negative 7, negative 6, negative 5, negative 4, negative 3. Either way is fine as long as you have 5 points represented in your XY chart. Okay? Questions there? All right. How do I find the Y values? Plug them in. Do I plug them into here or to here? The one on the left or the one on the right? The one on the left, because that's where I pulled out the first point from, right? So I got to plug these guys in there. Now, I already plugged them in. You can take the time to go ahead and do that to check my work if you would like to. I'm pretty sure it's correct. But as always, if I made a mistake, correct me. Now, there's a couple points that clearly won't fit on my graph, but I still want to see them in my XY chart because I need to see 5 points there. So I'm going to plot the ones I can. Negative 7, negative 7, negative 1. Ignore that one. Negative 5, 3. And negative 3, 7. Those ones all fit on my graph. Now, those were the middle 3 points, correct? Yeah? Remember when we did these cubics, I said there's always going to be these 3 points in the middle, and then you've got 2 points out here somewhere? These are those 3 points in the middle. They've just been stretched, haven't they? So we're going something like this. This is where the funky bend is. It's not the prettiest graph, but it'll do. And that's all I need for that graph. So? Okay. Any questions before I move on to the next one? All right. Tomorrow I can't answer questions, so make sure you ask them today. All right, number 8. This one messed with a lot of people. We have a cubic equation, and again we have the parent function graphed. Do you see that? And we're trying to find the equation of the new graph right here. Now, hopefully the first thing that you're able to identify is the fact that H and K are now in a different location. Another way of saying that would be look at your inflection point. It has moved. The original inflection point was at 0, 0. Now where is my inflection point? Negative 2, negative 4, right? That's my inflection point. That's my H and my K. So H is negative 2, K is negative 4. Why is that important? Well, if I refer back to up here, my cubic equation is pretty similar. But I now know these two values of my equation. So I know I'm going to have x minus h, that would be x minus negative 2, or x plus 2, cubed. Why cubed? Because it's a cubic. And then my k value, the minus 4, hangs out at the end. And now I got to figure out a. That was fun. Fun people in the hall. Okay, so to find a, first off, if you can at least get h and k in there, you've gotten yourself 2 of the 3 points. Okay, so that's better than nothing. To find a, bear with me for a minute. You're going to wonder why I'm doing something, but I'll explain it in a minute. Now remember, just like I said up here, you have 3 points in the middle when you're graphing your cubic. And on my parent function, they're all 3 right in a row right there. Here, the 3 points are given to you. Sort of, you can see them. Now, if I look here, I'm going to take my inflection point and the next point directly to the right of it, and I'm going to make a box as if those 2 were on the diagonal corners of that box. I'm going to do the same thing with this one. I'm going to take the inflection point and the next point to the right, and I'm going to make a box that has those 2 points as my diagonal corners. Why did I do that? Yes. I took this point and this point, and I basically made a box that was that high and that wide. Same thing here. This point and this point make a box that goes almost as if you were counting like a slope, if you will. Okay, so let's look at this box. This box is 1 unit wide and 1 unit high. This box is 1 unit wide and 3 units high. Is there a horizontal change? Not if both these boxes are only 1 unit wide. If there was a horizontal change, they would be different sized boxes. Is there a vertical change? Yes, because the original one was only 1 high. Now it's 3 high. So what does that tell me about my A value? We have something that is 3 times as tall. So? Now, the other thing I have to make sure that I recognize, there's 2 ways I can think about it. If I want to think about the boxes, this one was going up. This one is going down, which means there's a reflection, so I have to call it -3. Or the other way I can think about it is if the right side of my graph is going down, I know that that leading coefficient has to be negative. Okay, so I throw the -3 on there, and there's my last point. Okay, questions there? Yes?
If the horizontal shift of the box wasn't 1, what if it was 2? How would you like to do it?
If there was a horizontal shift of 2, you would put 1 over 2 right in here.
Okay,
Because that would be your B value. Okay? All right. Choose true or false for each statement about this function. Now, this function, I notice a couple things. We have a negative leading coefficient. What does that mean about the right side? Right side is going down. We have an even function. What does that mean about the left side? Also going down. And then how many bends would there be? 23. I'm not going to draw all 23, but we get the idea of what it would look like. Yeah? The domain of this function is, what does that mean? That means all real numbers. It also means -infinity is less than x is less than +infinity. Is that true for this graph? Yes. Left to right, we're going on forever and ever and ever. Is the range also all real numbers? Does it go up and down forever and ever? Does not go up and down forever and ever, so this one is false. There's a distinct top place there. All right, end behavior. As x approaches -infinity, what side of the graph is that talking about, left or right? That's the left side. Is my graph going down? Yes. As x approaches +infinity, that would be the right side. Is it going up? Nope. Okay, questions? Ready to turn the page? This is my favorite page. Oh, you don't have to turn your page, but I do want to say something. When I had, when I was grading these right here, when I was grading these, there were some groups that, like, when it said T or F, they would put something like that. And That's not 100% clear to me whether you're saying that F is the right answer or T is the right answer, especially if on your next one you do something like that. I get confused when you go back and forth. Please just circle. Don't use the X. Don't make me look for the correct one. Circle the correct one. Okay? You want a happy teacher grading your test, not a frustrated teacher, right? Wink, wink. Okay. This graph. What's my leading coefficient, positive or negative? Positive. How do I know? Right side's going up. Is this odd or even? How do we know? Opposite directions. Least degree. I see 2 bends. That means the least degree must be a third. There were people that would circle the word odd and then put like fourth right here. If you say odd, this number better be odd. If you say even, the least degree better be even. Okay, make sure that matches. End behavior. What's going on the right side? X going to positive infinity is the right side. Going up. Left side going down. So that would be to negative infinity. What's my domain? All real numbers. And my range? Also all real numbers, because I have an arrow going up and an arrow going down. Okay? All right, next one. Is my leading coefficient positive or negative? How do I know? Right side's going up. Is my degree odd or even? How do I know? Both are going the same way. Least degree, I see 1, and if I have an inflection here, that's 2 bends. So what's my least degree? Fourth. Again, I circled even, so I better be writing an even number right there. End behavior, doesn't matter if I can tell the difference, but this says the right side is going up and the left side is going up also. What's my domain? All real numbers. What's my range? Looks like -5 is the bottom, so you can either say y is greater than or equal to -5. That's my preferred way because it's easier for me to read. You can write -5 comma positive infinity. You do have to have the square bracket on one side and the open parentheses on the others. Or you could say -5 is less than or equal to y is less than positive infinity. Any one of those ways is appropriate for that answer. Okay? So? Good answer. Number 12. Leading coefficient, what is it?
Negative.
How do I know?
Because the right side's going
Right side's going down. Odd or even?
even.
How do I know?
Because
Both are going the same way. What is the least degree? I see 1, 2, 3 bends, so my least degree would be a fourth. End behavior, the right side is going down, left side is going down. What's my domain? All real numbers. What's my estimated range? Y is less than or equal to 6. Or I could write, hang on, let me get this right, -infinity, comma 6. Has to be in that order with the square bracket at the 6 and the open parentheses at the -infinity. Or I could write -8. Negative infinity is less than y is less than or equal to 6. Okay? Questions there? All right, number 13, super fun question. Write a function in intercept form, which means I'm looking for intercepts, specifically x-intercepts. How many times does this graph cross the x-axis? Cross or touch the x-axis? 3 times. Once, twice, 3 times. First time it crosses right there, that's at -1. So in parentheses for intercept form, that would look like x plus 1. What kind of a crossing is that? A kiss, a cross, or an inflection point? That's a kiss. So what does that mean about the parentheses? That has to be squared. If it's a kiss, that has to be squared. Okay. All right, my next one is at x equals +1. So in parentheses, that would look like x minus 1. Is that one a kiss, a cross, or an inflection point? Inflection point, which means what about the exponent? Has to be a third, because it's got a multiplicity of 3. And then finally, I have x equals 2. Is that a kiss, a cross, or an inflection point? That one's just a plain old cross, so I'm going to have x minus 2 with no exponent on it. Now, this part messed with people a little bit. That part says include a constant term of a equals 1 or a equals negative 1 based on the end behavior picture. My equation right here looks pretty accurate for this, except for the fact that what do you notice about the ends? They're going down, which means what about the leading coefficient? Has to be negative. So that statement right there is saying at the very end, check your end behavior because you may need to make a negative sign right there in order for the end behavior to make sense. If it was going up, I would just leave that blank as a positive. Okay? Any questions about that one? Still doing okay? All right, number 14, sketch a graph of y equals negative x to the 5th, blah, 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 blah. It's in standard form, so I don't care about the rest of the terms right now. I only care about that guy. No need for x and y axes. Some groups still felt the need to put an x and y axis. You don't need one. This is the question where I'm only concerned about the ends and the bends. So, negative leading coefficient means right side goes down. Odd degree means left side goes up. 5th degree means I have 4 bends. 1, 2, 3, 4. All I need is something that looks like that, and I got all 3 points. Okay? So for that one, I gave 1 point for the right side going the right direction, 1 point for the left side going the right direction, and 1 point for the number of bends being correct. Okay? Questions? All right, last page. Here we are in intercept form. Let's see. What is my intercept from right there? 2. And my intercept from here is, that's all I need on that line. Okay? Little public service announcement. If you're watching this video from another class, make sure you write that in the way your teacher requires you to write it. I only require just those 2 numbers there. Okay. If you write them as points, that's fine. You could put 2, 0 and negative 1, 0. Just make sure you put it in parentheses. Okay. Yes.
You don't have to put like multiplicity.
I don't need the multiplicity for this. We identified the multiplicity in last chapter's test. This one I'm more concerned with, do you know what the multiplicity is reflected as in the picture? Okay. All right. So I'm going to plot those two. I have positive 2 and negative 1. What's my leading coefficient, positive or negative? Positive, so what does that tell me about the right side? Right side is going up. And what are we looking at for degree? 1, 2, 3, 4. So the other side is also going up. So my end behavior, right side goes towards positive infinity, left side goes to negative infinity. I think I tried to give you a little extra space there because that can get kind of squishy there. Now, why is there an XY chart? Well, if these are both, let's see, at this one has a 3rd power, which means what about that root, or about that 0? It's going to be an inflection point, isn't it? So it's going to go something like that. Funky little wiggle there. This one's just a straight cross, so we'll have to see. But I don't know how low that's going to go. I know it's going down there somewhere. I don't know if it's a really shallow one or if it's a really deep one. So I have 2 values there. Please do not pick 0.5 and put it on your XY chart. Use nice numbers whenever possible. So what should I use? I should use 0 and I should use 1. Some people went way overboard and had like 8 points on their XY chart. I don't need 8 points. I only need 2. How do I find the y values once I have the x values? Plug them in. So 0 minus 2 is negative 2, cubed is negative 8, 0 plus 1 is 1, times negative 8 is negative 8. And 1, let's see, negative 1 cubed is negative 1, times 2 is negative 2. So 0, negative 8, and 1, negative 2. So I need to draw my graph as carefully as I can and connect those 2 points. Now keep in mind, right down here, a lot of people did this. That is a curve on the bottom there. It is not a V. So as best as you can, make it curved as opposed to like a vertex, like that. Does that make sense? So that's all I need for the XY chart. I know the XY chart looks really long and it looks like you need a bunch of points, but you don't. I just need to see what's going on between those intercepts. Okay? Questions there? All right, last problem. What is my intercept from here? 2. What's the next one? Negative 1, negative 2. So I'm going to graph those. 2, negative 1, and negative 2. My leading coefficient is negative, which means the right side is going down. My degree is what? 2, 3, 4, even, so this side's going down as well. And there's only one that has an exponent. That was at positive 2. So what does that tell me about positive 2? What kind of an intercept is it? It's a kiss. So it's not going to go through. It's going to kiss it and come back down. Again, it's a curve, not a point like that. So let's see my end behavior. Both of these guys are going down. And I need to know what's going on between these. The other two intersects are both crosses, correct? So this is going to go up, and then at some point it's going to have to turn around because this guy's got to go through the x-axis there too. So how can I connect these two? How do I know how low to go? Well, pick values between there. Again, please don't pick 0.5. You got two nice numbers there, so pick 0 and 1. Most groups got that. When you plug in 0 into here, what do you get? Negative 8. When you plug 1 into here, what do you get? Negative 6. Plot those 2 points. And that shows you how far down you got to go for that. Okay? Now, some people stopped there. A lot of people stopped there. Or they just drew like a little arc to connect those two. That's not the point of this. I got to figure out how high it is between those two. So what would be another value I could put on my x's that would show me what's going on between negative 2 and negative 1? Negative 1.5. Now that one I can't avoid it. I have to use a decimal because there's no nice number between those two. Plug negative 1.5 into here, and I ended up getting a value about I think it was 3.06, which I just rounded off to 3.1. So I put that value in there, and that actually goes up kind of steep right there, and then I just connect it down. So my entire graph goes up really tall there, down, and up. Okay, any questions? All right, that's the end of that guy.